Gary, are you alright? Mr. Ryan, are you alright? Yeah. So what's dynamic programming? We talked about this a few times ago. Dynamic programming. In one word.
Minimization and top down and bottom up.
Okay, so what's minimization? How do you spell minimization, by the way? M. Okay, station. It's a word for remembering, yeah? Remember. We want to remember the computer, computed results, yeah? So we don't want to recalculate it over and over again. And specifically, we can put the cache thing above the function, the methods. So you ask the computer to remember it, yeah? To remember it, okay? Yeah, that's and we have two kinds of dynamic programming, top down and bottom up. Depends on just think about the Fibonacci number. Yeah, Fibonacci number. The Fn equals Fn minus 1 plus Fn minus 2. Right? If we compute from Fn, and then we need the Fn n minus 1 and n minus 2. For n minus 1, we need the n minus 2 and n minus 3. Right? It's a tree. Right? It's a tree. Look, if we want to compute Fn, and then it'll become Fn minus 1 and Fn minus 2. And look, we want to compute Fn minus 1, we need the Fn minus 2 and Fn minus 3, right? So look, if we want to compute this value, so we need two values, which is smaller. And then if I want to compute the n minus 1, I need the n minus 2 and n minus 3. So if we're going this way, that's top down. But if we're going from that way, if we start from F0 and then F1, F2, that's bottom up, right? Top down, you can just say, okay, define f, right? You can say define fn, and if n equals 0 or n equals 1, return n, right? And otherwise I return fn minus 1 plus fn minus 2. Okay, this is the top down, yeah. Because look, can I have your attention, please?
Yes.
But this is expensive. Why is that? Look. Fn minus 2 here, Fn minus 2, right? This could be a lot, right? Look, it will be Fn minus 3, Fn minus 4. Again, look, Fn minus 3, Fn minus 3. It's expensive here, Fn minus 3. Yeah, and then Fn minus 4. Look, how many times I need to calculate this over and over again. But if I magically put this here, and I just need to remember n values. So look, the first time I calculate Fn minus 2, I save it. So next time, I won't continue this way because I already know it. Right? Dynamic programming, okay? So we have an array of numbers, 1, 5, 11, 5. Can you separate this array into two subsequent? Okay, remember the subsequent, and then the sum will be the same. Okay. Do you understand the problem?
This is.
Okay,
this and this with.
What? Subsequent. Which is subsequent?
1, 5, 5, another 1.
And 11. Well done. Okay. Okay, can you go back? Okay, this is not dancing class. Okay. So look, yes, subsequent and sublist. What's the difference between subsequent and sublist? Can you tell me? What's the
one of them is continuous and one of them is.
Okay, the subsequence is not continuous. Subsequence is that the original array, and we can. Okay.
I said subsequence was.
Okay. Look, listen to me.
Not continuous. That's what I said.
Okay. Subsequence, not continuous. It's like the original array, and then you can remove 0 or more characters, numbers, right, on it. For example, 1, 5, 11. If I delete 5 and 5, and then remaining will be 1, 11. Is a subsequence. The sublist is continuous, right? You pick. Remember the Cn1, Cn2, right? Cn1 plus Cn2. Cn1, I have n elements. I pick 1. This is the number of ways of picking 1 out of n. I have 3 apples. Ryan, you want to pick 1 to eat. How many ways? How many apples can you pick? How many different ways? 3, exactly. Okay. So Cn1 means. Yeah, Cn1 is the meaning that the sublist with only one single element. And Cn2 is like you pick two index, left and right. You pick this, you pick this. There are n elements, you pick 2. Okay, and then 1, 5, 11. This is the sublist. You pick this. You pick this. 5, 11, 5 is a sublist. Okay, so if you do this, that will be n times n plus 1 divided by 2. This is the number of the total sublist, continuous, and that's the in the scale. If you want to brute force it, that's O(n) squared, right? But for subsequent, we can think it this way. For each number, we can pick or not pick, right? That gives us two choices. For the second element, we can pick or not pick. Give us another two choices. So do I need to plus them or multiply? One question.
Multiply.
Multiply. And for the third one, I can pick or not pick. So and I can multiply too. So if there are n elements, what's the time complexity?
2 to the power of n.
Yeah, well done. 2 to the power. This is exponential. If you plot it, it will be something like that. Yeah, 2 to the power of 1 is 2. 2 to the power of 1 is 2, and you know it's very very steep the graph. Okay, so if we want to brute force this, right, we can try every subsequent. We can generate this, each subsequence, and then for each one, yeah, we can get the sum of it. So, and then we can check if it's equals to what?
2, 0.
The total sum. Look, the total sum of this is what?
22 even.
Okay, so for the subsequence, we want to check the subsequent sum equals to what?
Even to an even number.
Yeah. If it's even number, we can find maybe we can find the solution. But if it's odd number, it's not, right? If it is 23 or 5, there's no way to split it into half, right? Yeah? Okay, but look, okay, guess 22. This is the total sum for the array. And I want to find the subsequent sum that equals to what? To what?
11.
11, well done. Half of it, yeah? 11 half of it. So that takes, to get the sum of the subsequent, that takes O(n) times. So altogether, that will be O(n) times 2 to the power of n. Right? N times 2 to the power of n. This is quite slow, okay? So we want to use the dynamic programming to save it, yeah? Because look, we can come up with a function, okay? Come up with a function. So basically, wait. As we talked about, for the ith number, for this number, we can have two choices: pick or not pick, right?
Yeah.
And then we also have one dimension, which is the remaining sum. So at the beginning, we give half of it, like 22, we give 11. And if we decide to pick the number, we subtract the number from 11, right? And if we are reaching the end, and then if any time we're reaching the end, so we can do what? We need to find out if the sum is reduced to 0, okay? So let's first of all subset sum, and then we have nums, and then let's say total. Can I have your attention? Not too loud, please. Total equals sum nums, okay? That's O(n), right? But that's okay. This is some function. We can use the mathematic built-in function sum function, okay? Or we can do this. And total equals 0 for I in nums, and total plus equals I, right? This is the same thing. That's O(n), right? That's O(n). If total divided by 2 equal 1, yeah? What does it mean? And then we need to return false. Can somebody explain to me what does this mean?
We want to check if there's an odd number.
Yeah, if it's odd, then there's no way to split it into half, right?
So return false.
Yeah. Or modulo 2, yeah? Or we can do this n1, it's the same thing.
Modulo 2 is 0.2.
Yeah. Okay. Now the half will be total divided by 2. This is the sum, okay? Then let's come up with a function. Define dp. And now we are considering the ith number from the left to the right, okay? And then we are considering the sum s, right? Look, if I equal length nums, yeah, we are running out of numbers. Then we need to find out if the sum has reduced to 0, right? Yeah?
Yeah.
Make sense? What did I just say?
We're checking if it the number reduced to 0.
And what cases we need to do?
Find if it's even.
No. If we're considering the numbers, numbers. From left to the 0, index, right? Index I. Index I equals 0, the first number. I equals length n. We are now at this point, we are running out of numbers. If we are running out of numbers, we need to check if the sum has been reduced to 0, okay? Otherwise, we can just do what? And look, at any point, if the s is reduced to is below 0, what does it mean? What should we return here? If the sum has been reduced to 0, become negative, so what should I return? True or false here?
True. False. True.
Come on,
true.
think about it.
True.
Why is it true?
Because it's even.
No. I mean the sum false. Yes.
Oh yeah.
If falls below 0, it means right we are using too much sum, right? So in this case, it's not. This is not a way to split the array into half. Okay. Then now I just need to do what? Return dp. If I pick the choice, if I pick a number, okay, look, I plus 1 and then s minus what? Nums I, right? If I pick this number, or if I don't pick it, dp what? Can you tell me? If I don't pick it, what happens?
If you don't pick it, you will.
What's the first parameter if I don't pick it?
The first parameter.
If I look this, I'm at the i's number here. I'm here. If this number I don't pick, so what happened? I should move to the next. So I plus 1 and then what's the sum? If I don't pick it, what's the sum?
The sum if you don't not pick us.
If I pick it, I need to subtract. If I don't pick it, what happened?
You need to be the same.
Be the same. So s, right?
Oh
Yeah.
yeah.
What's missing here?
Cash.
Cash. If I don't pick cash, yeah, there will be multiple times this intermediate value being calculated again. But if I put the cash, what's the time complexity? If I put the cash,
It's
look at s.
Baby.
I is the what? Length of the numbers, right? Then s is half of the total. So okay, let's say half the total sum, right? So sum, let's say sum is s times n, okay? The time complexity is s times n divided by 2, and we drop the constant, right? Because this is the total sum, we are looking for half of it, s times n, right? So look, this is the total number of the maximum values we can cache, right? We can cache, and that also means the time complexity, right? So look, make sense? Yeah. For this number, I'm standing at this point. Looking at the ith number. For this number, I can pick it. Yeah. Or I don't pick it here. In both ways, we need to move to the next number. And when we reach the end, we have to check if the sum is 0. If we reduce to 0, then that's a good split. Okay? And at any point, right? If the sum already falls below 0, so we don't pick. Right? Make sense? Yeah? So okay, by the way, these numbers are non-negative, okay? Yeah, non-negative.
How about decimal things?
No decimal thing. No decimal. Just positive integers, okay? Okay, that's it for today. Tomorrow we'll talk about the bottom-up solution for this one. Okay, it's quite similar, okay? Bye-bye.
Bye bye.